Okay, I think we should begin. And well, good afternoon, everyone. My name is Mary Ong with Integral Group. Welcome to the Sustainable Labs Canada panel discussion on the future of labs, changes in facility and operational design. As workplaces are reopening and more staff are returning to work, how will the operational procedures in labs change for the foreseeable future? And how can the design of labs adapt and support new operational procedures? Today, the panel discussion will explore a number of issues surrounding how labs adapt to the new norm, whether it's operational or behavioral. The format of today's webinar is that we'll have about 40 minutes for panel discussion with 10 minutes of Q&A at the end. If you have any questions that you'd like to ask, please post them using the Q&A button at the bottom of the screen. A copy of the recording of today's webinar will be available on the SLCAN website. And now I hand it over to Kevin Shea to introduce our panelists.
You're on mute, Kevin.
Sorry, everybody. Has to happen to at least one person. So it was me. Sorry. So I'm Kevin Shea. I'm a principal with the AME group out in Vancouver, and have been fortunate enough to help put on this webinar presentation and panel discussion. And I'll be introducing Jennifer Wilshire. Jennifer is a lab manager with Stem Cell Technologies here in Vancouver with the R&D department. She's got a BSc in microbiology and immunology from McGill University and a PhD in immunology from Stanford. She has worked in Boston and New York and moved back to Vancouver in recent years and has a focus on flow cytometry. She is a great perspective from a private R&D laboratory as the lab manager that has had to maintain operations throughout this pandemic. We're really excited to have Jennifer here today to be part of this discussion. And I'll turn it over to Peggy to introduce our other two speakers.
Thank you, Kevin and Jennifer, and good morning to all three of you from Vancouver. I'm Peggy Theodore with Diamond Schmidt Architects, principal there. I will be introducing first our next panelist is Aurel Tambouri. I would like to tell you a little bit about him. Aurel has over 25 years of progressive experience in laboratory operations, safety, and support services. Since 2000, Aurel has held a few key leadership roles with the Ontario Ministry of Health and Long-Term Care, along with the Public Health Ontario. His area of expertise includes safety and biorisk management, laboratory operations, process design, program management, and regulatory compliance. Aurel is a member of the College of Medical Laboratory Technologists of Ontario, has earned a master's degree in health management from McMaster University, a graduate diploma in occupational health, safety, and environmental medicine from McMaster University, and is a Canadian registered safety professional. Over the years, Aurel has managed several clinical and service-related program areas, led various initiatives in process and quality improvements, transition plans, and continues to strive to build efficiencies within PHO laboratory operations. I am fortunate to have worked with Aurel on the new laboratory headquarters, and we welcome you, Aurel, and look forward to hearing about what you and your team have been doing and managing your facility and operational changes at PHO while maintaining your operations to meet the intense testing demands of this current pandemic. So thank you and welcome.
Thank you.
And our moderator and panelist, Ian McDermott. Ian McDermott is the head of planning and integration, space management, and capital project planning for all areas of the organization and senior director of research facilities at University Health Network in Toronto. He is also, as many of you know, the past president of Sustainable Labs Canada. Ian is a member of the senior management team for research at UHN for the last 23 years and is also a member of the senior leadership team at UHN Facilities Maintenance Planning, redevelopment, and operations. In his current role, Ian works intimately with clinicians, educators, researchers, administrators, project managers, engineers, architects, contractors, building operators, vendors, and regulators in managing space and designing academic, healthcare, research, and education space, while also focusing on operational parameters. Ian strives to ensure that these environments continue to be leading sustainable environments meeting the needs of UHN. With a clear focus on these needs of the clinicians, educators, patients, and researchers, Ian has been instrumental in developing effective, efficient, and safe workplaces that are sustainable while continuing to meet all the regulatory guidelines. For the last 7 months, Ian and his team have been focused on managing the physical and building operational needs as we respond to COVID-19 challenges. The impact has been acutely felt throughout UHN in research and clinical labs and all areas of patient care and education. Ian also holds a specialist degree in molecular genetics and molecular biology from the University of Toronto. We welcome Ian. So with this, I pass the presentation on to you, Ian, to lead the discussion, which we know will all be very engaging for the audience. So thank you, and we'll get started.
Thank you very much, Peggy, Mary, and Kevin. It's great to be here, and it's a fascinating topic. I know everybody's interested in it. Thanks to Jennifer and Aurel for joining us as well. With that, I think we'll dive into the first question. And just a reminder to the audience that you can submit your questions and answers, and our SLCAN members are going to bring those together, and they'll send them to me as in groupings. And if we don't get through all the questions, we will tabulate them and we will generate answers and be able to distribute those answers later. So I'll start off with the first question. Really, it was around what operational or design changes have been made to your existing organization since the start of the pandemic. And so I'm going to turn to Jennifer first. And Jennifer, maybe you can tell us what's happened there.
Sure. Thank you very much for having me, and looking forward to hearing from everyone about this topic. So at Stem Cell Technologies, March hit us like everyone else, and we ramped down, trying to minimize the number of people in the building, but keep operations going. It was key for us to be able to, many of our products are used were used to identify COVID in the first place and to do research on it. So we wanted to make sure we could keep that going. It was key to ramp down, but in a very careful way, prioritize and then plan. And so we ramped back up a couple months later to try to bring all the staff in the labs and manufacturing back. And lots of planning went into that, and lots of changes, as your question asks. And the main things that we did were put shifts in place. So a morning shift from 6 a.m. to 1, a break for cleaning, and then a 2 p.m. to a 10 p.m. shift, although those hours could be expanded as experiments needed, because as many of you know, if you're doing experiments, they don't always fit in a nice time slot like that. Shifts, masks, and identifying work areas. We called them work areas. So biological safety cabinet, a bay, a fume hood, a bench, a piece of equipment where we had sign-ups. So people would sign up for the equipment or their work area, and they would use only the time that they needed. And that was how we could ensure that people were not having contact, being defined as more than 15 minutes face-to-face within 2 meters. So it was contactless workspace. That was then, we had enough space because we had shifts. And the shifts also helped us because our cohorts then were smaller. If we had some business continuity requirements, we definitely have business continuity requirements. So if one person is ill and a cohort needs to be isolating at home, then the other cohort can pick up. So the other shift can pick up the work that has to get done, particularly on the manufacturing side. That's really, really important. So we basically ramped down, changed a lot of our operations, and ramped back up. We didn't do very much, many changes physically to the lab. because our revenue was lower, as everybody's company's revenue. All the labs were shuttered, and especially in academia, where much of our profit is, or much of our products are sold. So we couldn't make a lot of big changes to the lab. We used instead operational changes.
That's great. Jennifer, just a couple questions on that. So just to give some context, how big is the lab and how many people were being impacted here?
In R&D, we have about 200 people. And so many of them, we were, during the ramp down, there was about 30 or 40 people in prioritized projects, again, related almost exclusively to COVID products.
Right.
And getting new products out that would help cell culture media for different lung cells. And so then it was, then we ramped back up, and now everybody's back in the lab on a shift. Okay,
so you're back to 100% now.
We are. We stopped our co-op program, so that was 40 people of those 200 or so. So right. So we're back up to without the co-ops. Yes. Yeah.
Right. Okay. Thank you. So Arl, I imagine your experience was not about ramping down.
Absolutely not. I still recall having our first initial meeting in November in a boardroom speaking about Wuhan and something unusual happening there. From November to December, we started pre-planning some of our lab systems to ensure we have the appropriate means to start testing for this novel virus. Then we refer to as novel coronavirus. So as you can imagine, things took off. By February, we had ramped up production, which really meant how could we provide sustainable solutions and testing capacity for the province. So that's where it really started. Initially, we brought in, we used existing equipment, but quickly realized that that would not be sufficient really to maintain the growth of testing and capacity. So looking at our network system, we have approximately 400 staff, and we have molecular platforms and high throughput sequencers and molecular platforms with built-in automation. So we started ramping those up, which really meant looking at the physical condition of the space and what we needed to do. So as Peggy alluded to, we worked together closely on the building here at 661 University. And part of the design concept that we initially laid out was, how could we ensure we have surge capacity? How can we ensure that the lab structure, lab design is adaptable and quickly retrofitted to accommodate a quick turnaround for such exigent events that do take place. Because of that fortunate foresight, we planned very carefully in the space itself. We occupy approximately 170,000 square feet just at 661 University. And by having that, we use a mixture of closed rooms and open labs. Open labs provided great concepts for collaboration, research, but have impacts when you have an infectious disease that is unknown. How do you maintain it? How do you ensure that there is appropriate means to contain it? So by blending closed rooms with air-controlled systems all in place and open lab, we're able to balance that. What we also learned is that bringing in large pieces of equipment require a quick retrofit of casework. So we're able to demount these modular units quickly and actually begin rolling out some of the large platforms that are quite significant in space and time and heat. So we're able to quickly make those changes in approximately overnight. Actually, I'll step back a little bit. We had one significant change that was done overnight, and we had one of our big vendors bring in a very large piece of equipment, and they were able to start installation that took approximately a week. So because of that quick turnaround time and agility and lab design, we were able to implement that large piece of equipment that has a high throughput capacity for the COVID serology, the COVID PCR testing. So it's all about blending the closed and open systems and adaptability. Also, we're ramping up from a 400 staff network here at 661 University, plus our regional sites. So we're looking at probably up to 200 plus thousand square feet of lab space. The older labs, more challenging to retrofit space. We learned that, but as we, lessons learned from 661, we are building a new site in London, Ontario. All those best practices that were applied here will be implemented as there. The same combination and mixture, convertible spaces from a BSL2, BSL3 environment, we're able to do that. All those elements need to be taken into consideration just to maintain that adaptability. So for staffing wise, we're from 400, we're ramping up to an additional 500 people. So we could have up to 900 people effectively working at our 11 sites.
So that's an interesting point, and I think Jennifer alluded to the fact that they extended their working hours. Is that because you've extended your working hours, extended the number of days you're working? Is that something that had to come into play?
Oh, absolutely. Thank you for reminding me of that. Yes, we actually went from a very modest Monday to Saturday shift days only to a three shift 24/7 operation to accommodate that testing volumes. So the space itself had to be amenable to that and have that staffing volume in place.
That's really interesting. I want to come back to that shift to a 24/7 maybe in our next question. I just want to add a few things in terms of at UHN. Just I think a lot of people do know, but UHN, we have about 700,000 square feet of lab, and depending on how you want to count, we have anywhere from 1,200 to 1,500 people working in these labs. And when COVID hit, we shut down. I mean, the TASN group within, which is the Toronto Academic Sciences group, actually shut down their laboratories. And the only thing that was permitted to continue was anything that was directly related to COVID research. So it really had a major impact in terms of doing it. But in terms of ramping up, similar to what Jennifer has done at UHN, the group actually went to a double shift. But we actually threw in another part of it, in the sense that we started off at 25% of people coming back, and then we ramped up to 50%. But in order for people to be able to, at least everybody to come in, we broke it up into 2 shifts over 2 days. So shifts 1, 2, 3, and 4, and each group could come in for those periods of time. So every group got a chance to come in, but physically on site, we only ever had 25%, and then we ramped up to 50%, but still very much working in that 2-shift model, so that everybody is there, but it certainly changes things. I imagine for both Jennifer and Aurel, one of the big things for you would have been access control, which you would have had as a normal part of your operations. I wondered if did that change? Did you see any change? We saw some, and I'll talk about it, but I'd like to first hear from you. Did you change your access control, or did you have something already that allowed you to respond to this, this crisis? Jennifer.
We definitely had access control, but we could do a lot more if we had a better system, for sure. I would like to see people to be able to, we have better control over seeing the data from the card access. So, and having people be able to swipe out of rooms as well, and swipe out of the building, because we have a hard time determining how many people are on site at any given time, because we have no access on the swipe out. And
right.
We also have tailgate problems. So
Yep.
People tailgate in. So we have moved our reception and the security to the main floor, and done a few different things to try to work on getting better metrics, really, and be able to design things better and be assured that we're being safe. So I think we could do a lot better, but we definitely have control. I would like to see control at the room level as well better, so that we can see that where we have bottlenecks and where we have problems, which is only visually seen at this point.
Right. What about you, Aurel? I imagine you were already very tightly controlled.
Yeah, as a licensed facility under the HPTA, we're required to have a biosecurity plan based on our agents on hand. So we maintain high level of security, and simply put, we've had different levels of permissions depending on the job requirements of the positions. So we look at the job positions where their accessions should be permitted, and we scan it that way, and to ensure that access control is managed. So everyone who comes in is badged, they have an access control card, and the appropriate level permissions for their job required functions.
We're very similar within the research academic labs, in that we're still controlled by HPTA as well in terms of access, but it's controlling who can access in. But to Jennifer's point, one of the things that we didn't have was out. So we knew who was coming in, but we didn't necessarily know if and when they were leaving. So one of the things that we've actually asked the research teams to do is to tap out. So they need, not only do they, you don't have to tap out to get out, you can get out, but we've asked them to tap out. So it's a bit of an honor system there, but it actually allows us to then be able to go back and retrospectively say, okay, how many people did we have going in? I'm going to move on to the next question, but I have one question more for you, Jennifer, and maybe Aurelia, this happened with you as well. Operationally, between your shifts, did you find that you had to adjust your cleaning protocols at all?
Yeah, we definitely had to put them in place and find people to do them. That's not been that simple. We don't have enough people to clean the lab extensively. So really it's just the high touch points,
Right.
bathrooms, that kind of thing that get cleaned in the lab. The assumption is the PPE is being worn and staff are cleaning prior to doing their work. So
Okay.
It's your self-responsibility in the lab. Yeah.
In the lab, but then you have all of those common areas, or did you restrict all those common areas?
Like the lunchroom and restrooms and stuff?
And meeting rooms and entry
Yeah, we
doors.
don't, no meetings, all meetings are online. There's no one is in the building unless they need to do lab work and absolutely have to be on site. We don't allow anyone to come on site. So no managers, no
Right.
one who isn't needing to do, you're only in the office area if you're waiting for an incubation in the lab.
Right.
And then we do have the odd time, not the odd time, but we have one person sort of a rotating basis, sometimes myself, just double checking, make sure everybody's supported and has a more senior person on site, but we limit that quite significantly.
Right. Or I think you would have been in a different boat, right? Because you would have had people there for a shift and they would have needed to be there. And presumably they had to take breaks. And so how did you manage cleaning between breaks, or how did you manage cleaning in those common areas?
Yeah, absolutely. Yeah. So one of the things we did early on, recognizing that high touch points would be a high risk of contamination or cross-infection, we quickly enhanced the cleaning cycles here at 661. Primarily, it was continuous. From level 20 to level 17 on a continuous rotation basis. 2 individuals were doing that full time. All the high touch points, sinks, fridge handles, doorknobs, any area where we consider high touch. Bathrooms were cleaned extensively around the clock. And that we applied to some of our regional sites as well, just to ensure they had that. Where off hours, where it's difficult to have that done, we also encourage staff by providing all the necessary cleaning types, either liquid disinfectant or swab type disinfectant, that they would routinely clean after themselves. If they had a meal, they would clean at their touch of their chair, their table, refrigerator if they had touched, coffee maker if they had touched. So we had plenty of supplies. So the responsibility really through training education was done through our staff. In the common areas, in the laboratory sections, we have robust cleaning cycles routinely, just for that. It was part of our normal operations to begin with. A little bit of enhancement where we would more routinely clean computer keyboards if there's high touch points. Just take those precautions where necessary to enhance that. And we've done quite well. Yeah.
That's great. I actually am going to flip, because I think that's a nice segue, RL, into the next one. And it's always difficult to change human behavior. And some of what you've talked about is human behavior. And Jennifer, you touched on it as well. But what did you do to actually help change that human behavior? What was successful? And if you think it was successful, how do you know it was successful? So because we can put all the physical parameters we want, but if we don't change human actions, we're not going to be successful. So, or maybe going back, because you said, well, you put disinfectant around. How do you know it was used?
Yeah, absolutely. So we have what we call home bases or home stations for disinfectants, and actually it's monitored to see what the consumption is routinely. So we know, I mean, it's sad to say, but we know the counts of things were done, and that's how we're able to monitor. What's really important to recognize, staff watch each other. So if someone doesn't clean after themselves, it's, kind of is considered the peer pressure to ensure that universal masking is in place. That's another thing we implemented, universal masking when outside containment, where necessary, where the 2 meter physical distance can be applied. Again, that's through training, through education, through signage, reminders of staff, best practices that we routinely adhere to in the lab setting. It's just reinforcing. having professionals work in that environment routinely, they've come very accustomed to those innate behaviors and the recommendations that are put into place. I'm sure.
So what were you doing for the education side of it? I'm really curious to know what, beyond sort of you walk in and this is what you do today. Did you do something specific?
We did. We had our safety officer prepare lab hygiene, very basic hand cleaning, hand washing, when to use hand sanitizer, gloves on, off, removal, cleaning, and then also the high touch points, just simulations, like if you touch something and someone else came behind you and touched, how does that virus transmit? So I think through the visual cues that were presented in that training, they're able to actually physically see where the risks were. And everyone wants to protect themselves. More importantly, they want to protect their families. So when we look at it, the community as a whole, it's just one of those cascades of important details that need to be adhered to. And I think most staff, I'm happy to say, really followed that very, very closely.
Jennifer, did you experience the same thing, or did you find anything different in your environment?
Yeah, staff wanted to go back on site quite badly, so they were and we're scared, to be frank, so they were quite compliant, but just really tons of communication, and feedback sessions being held so people could feedback that the mask didn't fit around their ears or whatever it was, because we have masks are required all the time at stem cell when you're on site. So we had to have
pre-COVID or just during COVID?
Just COVID, yeah.
Okay.
Yeah, and so sort of two-way, really a lot of change management went into this to try to hear what people were saying, because many of the people making the decisions are not the people who are on site. Because
they don't have to wear the mask all the time?
Right, and they don't have to get up at 5 a.m. to be at work at 6, right? And try to get their experiment done. So we're trying to really make sure that both sides of it, if there's two sides, really the people who are on site and who aren't, really feel on the same team. And that takes a huge amount of communication and feedback sessions. And I ran I don't even know, 6 different feedback sessions to try to have people where they don't have, it's not a democracy, they don't have a vote about what safety procedures get put in place, but they can have their feedback, right? So it felt like they had some voice there. And I think that's been a positive going through. And also being on site and checking in on people, not checking up, but checking in and trying to have the tone not be the police. Although I do agree with Aurel that peers are your best enforcers in a lot of ways. So that's been helpful as well. We've had a lot of compliance, but also acknowledging that the stress on the staff who are going in, we really need to, when there isn't compliance, oftentimes it's due to some stress and some reason that is very, very valid and needs to be addressed.
Right. So I think within UHN we ran into very, very similar. The communication level escalated. I don't know but many folds more than what we were communicating with the teams beforehand. And the simple signage, and signage is now plastered everywhere, instructional videos on how to actually take a mask, put a mask on and take it off, because people don't know and they do that wrong. So just all sorts of videos, signage, and documentation in terms of providing checklists for people. Here's the things, and it may all sound really, really straightforward and basic, but when you have a checklist and you check it off and you say, okay, yes, I've done this, yes, I've done this. Because if you just rely on people to follow past habits, their past habits are going to fall into that pre-COVID timeframe. So you need to give people the tools, and I think that's what a lot of what we've been doing. I wonder if, sort of going a little bit back to question one, and Aurel, you talked a little bit about, you're designing the next level of labs in terms of where you're going. What are the elements either around the sort of the physical aspects that have actually allowed you to respond to this, and that you really want to keep, and that you would want to put forward in the future, and maybe even to yourself as well, Jennifer, the behavioral aspects that, this is working really well, regardless of whether it was COVID or not. Is this something we would want to maintain? And is there anything about your physical environment that would actually really help that? And I'll start with you, Aurel.
Sure. Yeah. One of the one of the really important features that we put in place here at 661 is really what we call the techno validation area. It is essentially about 1,000 square feet of lab space with overhead service carriers, no walls, everything is mobile. And typically that was used to validate new large analytical platforms that would be coming in through for validation. So you can configure the space in real time to accommodate any piece of equipment. All the services were available overhead, compressed air, water, power, data. So everything was overhead. Because of the validation work was quieting down, we actually repurposed that entire space for COVID response, where we're able to retrofit that space really just in a matter of minutes to sign up a team of people who then would apply the rolling table types, lock them in place, put all the all the peripherals that were required and the equipment that would be required in place in real time. That really supported our response. Starting with a couple hundred samples tests per day to even an example, the last few days, 12,000. You can imagine just the sheer volume. We added a bank of refrigerators. We added a bank of -80 freezers. We're able to bring in some personal containment enclosure, similar to a class 1 cabinet that people could use. So we're looking at applying engineered controls as quickly as possible, as opposed to using the personal protective equipment as a primary means of containment. So looking at that, we need to be, that was part of the adaptability and quick retrofit of time and space for us to really ramp up to that level of performance. That's one area. We have a few of those areas, and also we include robotics, and it just simplifies the whole process for high volume testing. Was a similar feature, but also the open demountable units, the wall units, the casework quickly could be removed. There's certain columns that have the power and data; those remain intact. So back to the example that I gave earlier was the high throughput molecular platform, which is literally like a small car. You want to bring in a small car, assemble it in place, and you want to maintain a level of containment around that. So the demountable walls could quickly be reassembled and actually form a wall. So now you created an enclosed space from an open space for that very close function. Typically, there'll be an anteroom in close proximity, so like a BSC, some of the preliminary, like the license buffer could be added, inactivations could take place, and then the testing could be done in an adjacent space. So workflow was really important. And I know, like Peggy recalls, the long, lengthy times we had with workflow design, how the samples come in through a loading dock, how consumables and supplies, reagents, all those items, the whole supply chain logistics elements need to be also looked at. How those are managed quickly and effectively, and how they're organized in a fashion that maintains that continuous workflow.
So your current design seems to be very adaptable to allow you to do that. So that's something I hear you're going to take forward in the future. Is there something that you're sort of, you've done now that you're sort of saying, no, I'm not going to be able to do that? And I want to ask more specifically around in the labs that you have, and it's a question that comes from the audience, more specifically around the ventilation side of the world. Did you have to change anything in terms of ventilation? Did you have to ramp it up? Did you have to run it longer? If you did, how did you do that? How did you manage to ensure that, was dealing, simple things like if you're adding all this extra equipment, you've got all sorts of additional heat load. How are you dealing with that? How are you making sure with all these additional people that you're keeping a comfortable environment for them, and a safe environment? I mean, if they're masked, you should not have airborne issues to worry about. But what happened around your mechanical systems?
Yeah, good point. Thanks, Ian, for bringing that forward. Initially, you think through building automation systems, the set points are based on heat loads, current working environment. With any changes, it requires changing to BAS programming, volume offsets, all that's done. So in real time. So essentially, as we include new equipment, we get the BTUs, number like heat loads that could be produced by equipment. We have our building automation people look at that and actually will adjust the inbound and outbound air in that very specific area. So that's easy to control for a modern day system without any addition of any enhanced systems.
So just for clarity, you said that you still needed a building operator to make those changes. They could see everything and they could see what the demand is, but it's still a building operator to make the changes?
That's correct. So essentially they are part of our facility management unit who are here
Right.
on site. Once we bring new equipment in, we're able to consolidate, have that discussion with them on the needs, and they're able to make those adjustments to ensure that the operators are comfortable with their environment. The equipment is actually in an optimal temperature for operating as well. We dissipate heat load, and we ensure inward directional airflow. One of the benefits
Yep. Go ahead.
I was going to add that each of the lab containment perimeter has a we refer to it as a transitional corridor. So that creates the air barrier between a clean area, transitional corridor, and the lab space itself. So we maintain, in most cases, inward directional airflow, and volume offsets are accordingly set that way. And they're monitored. We have display panels right off the bat, tells you which direction air is flowing, if you're green, if it's red, if it's reversed. Those are real-time data that all our staff look at before entering a space to ensure we have the directional airflow.
Right.
And that's actually closely monitored by our building automation system.
So I wonder, when prior to COVID, you had a building system, an automation system that was set for the basic parameters of the shifts that you had. When you had to shift to a 24/7 model, did you have to then run the system 100% 24/7? Did you have setbacks previously? Was that a change that you had to make?
Absolutely correct, Ian. We do have the energy recovery in the evening. We ramp things down to more of a modest exhaust. The lab itself operates on 100% exhaust and supply. So you can imagine running that full out all day long in an environment where you're only utilizing perhaps 10 hours per day is not effective or efficient. So
Absolutely.
by making the change to 24/7 operations, we had to then make that adjustment. So it's a full 100% supply and exhaust to maintain the current air exchanges per hour as we were defined to our regular shifts, and also maintain the directional airflow as well.
Yeah, I mean, that's great. I have to say, in UHN, I'm lucky enough to have put in a automated management system. So in addition to the building automation system, we actually have another monitoring system. We use Optinet, and basically in all of the laboratories in our 2 new buildings, which is the majority of our labs, and literally the system automatically sends a message to our HVAC units to either increase heating, cooling, whatever is required, increase air exchanges on that. So we actually don't rely on a building operator. We have more people in there, we've got more activity, the systems will ramp up. If it detects a contamination in the air, the system will ramp up. And when everything sort of settles down again, it ramps down. So it's a very automated system. So there was nothing we had to do with respect to that. Even having double shifts now, the system itself responded to what the demands were. And when there isn't anybody there, the system ramps down to an absolute minimum requirement. So for us, we already had something in place, which was fantastic. And I can tell you, just based on what we're doing now, I would never build a laboratory going forward that didn't have that, because you don't have to rely on a building operator, and you can change those operating times and frames and parameters and what you need in the labs without even really having to worry about it. It didn't cross my mind that we have to think about it, because it was already in place. I wonder, Jennifer, I know you're not sort of a mechanical in terms of, building HVACs or anything, but I wonder if there were design features within your space that you sort of look at and go, that was really helpful now, and we would continue that in the future. Or you're kind of going, that's a design feature that's a bit of a disaster for us and we won't do it again.
I think we need more space. I think that's really what it ultimately comes down to. And so going forward, to be able to plan, I hear Aurel saying a lot of times flexible, and that's not what we have. We have very fixed rooms, fixed, even if it's open, the casework's all very fixed. So I would definitely change that going forward so we could be much more flexible in the future.
Right.
And then honestly, it's just having enough space, because we have to do the shifts because we don't have enough space, because the contactless work environment is the key thing for us for safety. And so, and by that, I mean, we're trying to have enough distance between every work area, so that people don't have contact, the 15 minutes, 2 meters face to face. And so I think for me, it's mostly having enough flexible space, which is sort of a dream. I think that it may not, you know, it's complicated, of course, to have that.
Yes.
Vancouver is very expensive, and lab space is very expensive. So I think
Okay.
more of a dream.
I'm getting questions coming in fast and furious, so I'm trying to read the questions at the same time here. A couple of things, sort of going back a little bit. Were there measures that you had in place that actually said that it was safe, you had a safe return into the lab space? Now, Arl, you didn't have that because you just ramped up like crazy. But I wonder, Jennifer, did you have measures of, you know, that said, yeah, we brought back people and it's still safe?
Well, I think the no infections, and obviously then therefore no transmission. And there's quite a number of people, not just in R&D, the 200 I mentioned, but in the whole company that go back because they are in manufacturing. And we have a policy that any symptom is reported to safety, and safety does a risk assessment with you. Any even tertiary or quaternary contact with a case is reported. So we have a lot of people reporting, but ultimately no transmission and no infections directly of staff, as well as no transmission at
Right.
work. So I think that's our key measure. Hopefully that never happens.
Yeah, and I would say we had the same, right? So we were looking to see, would we have to ramp back down because we started to see transmission within the laboratories, and thankfully we did not. So so we were good there. I just want to, so there was a question that sort of said, you know, what about specifically about air quality measuring, and, you know, that it doesn't detect pathogens, and was that a concern? And I think that it's two answers to that one. First off, similar to what Oriel has, our mechanical systems for the laboratories are negative air directional. It is once passed through, which means it is coming in, it's conditioned, it passes through the lab, and it's exhausting through to the external environment. And so, you know, for this particular pathogen, is there something that we were concerned about that being in the air? The answer is no. Secondly, is that barrier protection, which is what, you know, Health Canada, what all of the literature is saying right now, is mask, because that transmission is either happening through touch, which means clean those surfaces, and so that's not an airborne issue, but then it's being masked so that if you inadvertently end up in the work environment, in the lab environment, and you happen to cough or sneeze accidentally, and you did have something not realizing it, it's contained by that mask. And again, everything is showing that the level of masks that we were wearing, certainly we were issuing medical masks and clean medical masks to everybody that was coming every day. So we weren't worried about that. I've also been asked to point out that the ASHRAE Epidemic Task Force Laboratory Subcommittee guidance document will be available shortly, and they are going to be talking more about mechanical systems. So that's great. I'm gonna just in watching time here, I'm actually going to jump down a little bit, and we've talked on this, but I've got some questions on that, and that's around design of entrances and how we manage it. And Jennifer, you mentioned tailgating, or I wonder if you have the same problem. I know tailgating is a big issue for us. But there was also, you mentioned, Jennifer, about tracking people and having them be able to card out as much as card in. And I'll come back to you, Aurel, and ask whether or not that's something you're actually doing as well. So Jennifer, what would you do to change your entrances to help manage things? Or I should say access points, not entrances.
So entrance to the building as well as entrance to the lab.
So access points, whether you're accessing into the building, into the laboratories, you mentioned some of it already, but also exiting.
I think for sure carding everywhere, in and out of everything. I would also love it if we have these work areas, as I mentioned, which is not exactly what you're asking, but these BSCs or fume hoods or benches, if people could card to those and then have because we have a Google system, we happen to use Google at work. So we do this Google Calendar sign up, but wouldn't it be cool if you could just tap in and we know then that you're using the sign you signed up for, and when you're done, it notified everybody you were done so someone else could get in there. We could have really, I think, an enhanced system for all of this if we use the badges in a much more effective way. I think a human also needs to be around. We have a receptionist and a security guard now in the entrance area. And this is the entrance to the building. That helps people do the right thing, maintain the distance, pick up the mask and do that correctly, putting on, donning and doffing, as well as not tailgating. So there's a human interaction piece that I think really helps. Even though that puts an extra person in there, which is a downside, I think the upside is really important to have a human greet you and help you, support you instead of, you know, chastise kind of thing. Yeah.
Right.
You're not
Earl,
anonymous.
would you add to that?
Yeah.
Sure. Yeah, so the lab design here really encourages, actually makes it mandatory to use card on entry and exit, particularly around the containment zone. So any area where there's infectious work happening, consider the containment zone. So those who are duly authorized to enter the containment zone usually use their card to, at a permission level, to get into the space. They may only be allowed to enter the transitional corridor, but not into the lab space itself, unless you have a permission. So that's another card access to get to the actual containment zone. From exiting the containment zone, usually it's a quick exit, but you need to card out to get out of the transition corridor. So there's multiple layers of inbound and exit, as well as some of the common areas. So we do monitor as closely as possible, in addition to CCTVs at key areas, which are also monitored and recorded for that purpose. Part of the initial design of the security system here was really based on threat risk assessment, understanding what the threats are, insider, outsider threats, access from the public. Based on the TRA, that's where we're able to implement those appropriate controls in place for access control. And that was part of our submission, of part of our biosecurity plan.
Right, right. I would agree that we need a different access, I would say, into our spaces, in the sense that we actually need to manage the exiting of the spaces. Right now, we don't have, I mentioned that, we don't have that. So we're relying manually on people's behavior to do that. All of our laboratories are card access, so that is actually relatively well managed. It's more the common areas that aren't. That are not controlled. So we actually don't know who's in what area. And if you think about transmission of disease, particularly COVID, it's those common areas that are certainly more challenging. I would also point out to people that that loading docks and delivery of materials from the external environment, depending on the environment and academic settings, those are very open and they tend to allow people to flow freely through those. And they're not really well controlled because you're relying on a dock master to control that. And the dock master is busy trying to receive materials, whether it's liquid nitrogen, other materials, et cetera, that they're trying to actually manage. And so it's definitely a concern. I would say for us, all our elevators are access controlled, especially in our mixed building. And Earl, I know you're in a mixed building, meaning there's many other tenants in the building. So only your staff can access the floors that your labs are on. And we have very much the same thing. So at least we prevent anybody from getting off on the floor if they don't tailgate. Once they get off on the floor, we do have another layer at the door where you actually have to tap into the floor. And so as long as, again, somebody doesn't tailgate, but you actually have to make sure that the lab staff actually maintain that they don't allow somebody to tailgate. And that's really hard because they don't want to feel like the police in terms of doing that. I want to, Jennifer, you sort of said that human needs to be there at the front. And have you actually seen anything where you truly felt that make a difference, or have you heard any research that says if you don't have a human, people are non-compliant, and if you have a human, they are compliant?
No, I don't have any research. This is just my gut feeling of also people feeling taken care of. And while they're there to police things, I think the tone really ought to be that we're here to take care of you and to welcome you and to help you. Because again, the stress of working on site in these shifts is difficult. So it's sort of about taking care of your staff, but I don't have research. It's my gut feeling that people need to be welcomed by someone, and that helps them follow the instructions and do the right thing.
I would tend to
Sets the
agree with you. I
tone.
mean, certainly in a hospital environment, which I'm looking after all the hospital environments, our entrances all are manned at this point. And simply because we're a public institution and people can come in and out, and we actually have to manage not just staff, but patients and visitors coming in and out of the facilities. But in some of the areas where we've said, you know what, it's only staff. So the only staff can get into this space. Do we still have to have somebody in? And we actually did. We put a real person there to be able to, validate that, yes, you answered these questions. Yes, you're free of symptoms. And by the way, here's your nice clean mask. And hey, we're here to protect you. We're here to help you. We're not trying to be a police. We're just here to make sure that you feel protected. In terms of what's doing. We actually talked about, in the research areas recently, talked about actually removing that human element. And at that, it had real mixed reactions. And at the end of the day, we've decided we can't remove that individual from that space. And so we're going to continue with that. Just looking at some of the questions here and just conscious of time, we're down to the last bit of time. And I'm going to put the, we got 5 minutes according to my clock. This seems to have come up, Oral, again, and I know you talked about it, but you mentioned having demountable casework and mobile equipment and these of configuring. And is that a key design feature in the future? And is that something you're going to put in your specs, if you will, for new labs?
Absolutely, Ian. That's really, it's a requirement now. It's not even an option. I think really to be flexible and have that adaptability in the future as programs change, as lab science changes, that's a must. Gone are the days, I know, just to give everyone a reminder, there's a picture behind me, that's actually our old site, 81 Resources Road, built in 1964, where they tried to include some of those modern features, demountable wall panels, centralized services. They were on the right track. But looking at some of the casework, it was fixed, difficult to move, big renovation to do any changes. You can just imagine. You want power, you want data, you want flexibility, you want to be able to be agile. And exigent events could happen anytime. You need to be quickly and able to respond to those. And having that, adaptability and flexible space to be reconfigured in a short period of time is a must for any diagnostics clinical lab or even research labs. I think the cost would offset some of the flexibility that the future provides and minimizing.
Yeah. I think I've often talked about it being an adaptability as opposed to flexibility. Flexibility is really expensive, but adaptability is something that can change readily without a huge amount of cost or time. And I think that's a big difference. Sorry, Jennifer, what were you going to say?
I just was very curious to hear, how do you make the BSCs and the fume hoods movable and
that's a good question.
Adaptable?
So at UHN fume hoods, those are fixed elements. We did not. I actually have seen biotech companies which actually use a flexible duct system, and they've had fume hoods connected with a flexible duct. And you do need a little bit of specialized facilities team to be able to move them around, but that was something I saw 15 years ago, and it was really well received. RL?
Yeah, absolutely. So we look at a number of different BSCs. All A2s, some are thin-bowl connected, some are hard ducted. That's a thing where the pre-planning takes into consideration. So depending on your environmental conditions, what type of work you're doing, the application. So we have a very good relationship with one of our vendors who, in a very short time, are able to be deployed and to rearrange BSCs, certify them within that 24-hour period. I think that's where you need to have the available supports as well. Where it becomes complicated, such as BSCs, fume hoods, they're fixed, they're not going anywhere. We know that. Also, taking into consideration what the risk factors are. So, as I alluded to earlier, looking at some personal containment enclosures for just handling of samples, an initial screen. Basically, a class 1 cabinet fits on a casework custom designed for that very function. They can be moved on a rolling table. They're checked for airflow. They're certified as a class 1, but that's again adaptable for the purpose and need that's required. when you need the big, 6-foot BSCs for a function. A little more challenging. Is it ducted? Yes, it's challenging. Is a thimble connected? Does it need to be thimble connected if it's moved? All those need to be balanced out and how your workflow is and how to integrate the systems together.
Absolutely. So we got 1 minute left, and I have one last question. Given that COVID has required us to have greater physical distancing between our staff, do you think that in the future we're going to build bigger spaces so that we can have more physical distance between staff, or do you think that's a temporary issue? Jennifer?
I think we have to build bigger. I'm not sure it's possible.
But okay, and RL, what would you say?
Yeah, I think it's how it's optimizing space to the best of the ability, right? So if you're using time and space effectively over a 24-hour period, you can multiply your spacing incredibly by utilizing it effectively. Looking at long-term strategy, labs are expensive, to run. We know that. We want to keep operating costs down as possible. Managing heat, airflow, all those things, power are expensive. So I would say use best practices. I think there's some good standards of practice of lab designs, and space allocation should be applied to research clinical diagnostics. I think our colleagues, architects, designers have really fine-tuned that. It may appear small at the end, but I think with the flexibility and all the design elements, that creates the space that you need in how work is conducted in the future.
I tend to agree with you, Earl. I think that there needs to be more work done just to see whether or not we do need to increase a little bit. On the one hand, Jennifer, I think the first gut reaction is to increase, but I think that we need to look at that time and place in terms of how spaces are used. The one place I would do, certainly in the academic lab environment, is all those support spaces, all those desk and office spaces, although we have to think about where that's going virtually now. Do we need that? But the lunch spaces, these break room spaces, I do think that we actually need to probably allocate more space, and those tend to get dropped off at the end. Anyway, it is now just gone past 1 o'clock, and I want to thank very much Jennifer and Aurel for taking the time to participate in this panel. I'm hoping the attendees, I think we had a really good attendance here, and I want to thank SLCAN for putting this on and asking the three of us to participate. And with that, I'll call it to a close, and I hope everybody has a great afternoon, and I hope everybody stays safe and healthy. Please pay attention to what's going on right now. Keep your masks on, wash your hands, and keep your distance, and we will all get through this. All right, thanks everybody. Take care.
Thank you.
Great.
Bye.